Hi everyone, this video is going to be everything to do with lines and planes. So we're going to look at the intersection between a line and a plane, the angle between a line and a plane, and the position of a line relative to a plane. In other words, a line parallel to a plane, perpendicular to a plane. So just a number of different examples here. First of all, the angle is pretty simple. We've got a line coming in here and we want to know what in this case is theta, the angle between the line and the plane. The way that we do this is that we find out the angle between the normal to the plane and the direction of the line, which is this angle here, and then just recognize that the relationship between this angle and theta is that they both add to 90 degrees. Okay, so we find this angle using the calculation. The actual angle we're after is theta. So our answer is going to be 90 minus that. Pretty simple. So and we're using this formula here, okay, for the angle between two vectors. So in this case here we just need to recognize that the two vectors we're talking about is the normal to the plane and the vector in the direction of the line. So typical question, find the acute angle between the line and the plane. Let's look at part A. So here, if we're looking at the line, we see that the vector in the direction of the line is 3, 5, 9. And the vector that's in the normal to the plane, or the vector that is normal to the plane, is 2, negative 3, 2. Okay, so that is the vector that we're going to find the angle between, and then just 90 minus that angle. So I'm not going to go through the full working here, but we could work out the dot product here. We get an answer here for the dot product or scalar product, and then we're just going to use this formula here. So we need to work out the length of each of those vectors and then rearrange this formula so that we get cos of the angle on its own. Once we've got our answer, 90 minus that will give us the answer between the angle between the line and the plane. Okay, well, what's going on now with the position of a line relative to a plane? Well, we've got three different things going on, so I want to examine each of these. First of all, a line could be parallel to a plane. That's the first one. The line could lie in the plane, or the line could intersect at the plane at one point. Obviously this is the one that occurs the most, a line intersecting a plane at just one point. We need to know that when we go through the procedure I'm just about to show you, what each of these is going to look like. So for this one here, we're going to get a solution for lambda. We're going to get a unique solution for the value of lambda. For this one here, the infinite solutions one, if we go to solve using the method I'm going to show you, then we're going to get something like 2 equals 2, something that's true but it's not going to help us to solve or find a value of lambda. For the first case here, we're going to get something like 3 equals 0, something that does not make sense. Okay, that shows that there's no solution. Okay, so we've got three different cases. It's the third case that I'm really going to look at. And we're just going to check out a PowerPoint, one example that will help us to do this. Okay, so here we've got the equation of the line and we've got the equation of the plane, and we want to find the point of intersection. They've used the parameter t here for the line. Sometimes we use lambda, sometimes mu, sometimes k. Doesn't really matter here, but in context we normally use t because t often means time in these things. Okay, so how are we going to find the point of intersection? All we're going to do is substitute in the coordinates of the point on the line into the equation of the plane and solve for t. So here's what it looks like. Once again, writing this out in component form makes it look so much easier. So let's do that. That's the line and that's the plane in vector form. So any point on the line, the any x coordinate is 2 plus t. The y coordinate of any point on the line is 3 plus 2t, and the z coordinate negative 1 plus 2t. So I'm going to substitute them into here for r for x, y, and z. So we're going to get that. Okay, remember r over here in the plane is just x, y, and z. We do the dot product on the left-hand side, and we get an equation in t, which we can then solve. So in this case, t is negative 7. That's the exact value where the line crosses the plane. So we then substitute t equals -7 in here to get the coordinates of the point where the line intersects the plane. So for our x coordinate, 2 plus -7 times 1 would be -5, etc. 3 plus -7 times 2 is -11. So there we've got the coordinates of the point, which is the intersection between the line and the plane. Easy. Okay, what else would we want to do? Let's have a look about this one here. How do we know that a line and a plane don't intersect? If we go through that same process, then we'll get something, an equation for t where we get something like 0 equals 5, something that does not make sense. Another way that you could tell is the dot product between the normal to the plane, 2, 1, -5, and the vector in the direction of the line. If that line is parallel to the plane, then the dot product between these two should be 0, right? Because the line and the plane are parallel. So the dot product between that red arrow, which is in the direction of the line, and the normal vector to the plane, that should be 0. So in this case here, if we do it, you'll see 2 plus 3 minus 5 is equal to 0. So that's another way to show that a line and a plane are parallel. Okay, last one. What about a line that's perpendicular to a plane? Alright, let's do this. So we want to find the equation of a line that's perpendicular to this plane here, and it passes through the point 1, 3, minus 3. A little sketch will actually really help in these. I know we can't draw the 3D version, but a little sketch is often very, very helpful. Okay, so remember we know that the equation of a line looks like this. So we've got the vector that gives us a point on the line, and then we've got this vector here that's in the direction of the line. So have we got a point on the line? We have. It's passing through the point 1, 3, minus 3. Have we got a vector in the direction of the line? Well, the equation of this line is perpendicular to the plane. That means that it's the same vector as the normal to the plane, isn't it? So here's our line. It's going like this. That's the same vector, or parallel, to the vector that's normal to the plane. So we know from this form of here that the vector that is normal to the plane is 1, 2, minus 1. And that's what I'm going to use here. 1, 2, minus 1. And there is the equation of the line that we want.